Okay, so we're going to talk about the pH scale. So if I have a high concentration of H plus ions, that means I've got a acidic solution, which means I'm going to have a low pH. And the opposite of this is if I had a high concentration of OH minus ions, that means I'm going to have an alkaline solution, which means I'm going to have a high pH. Okay, and then if I was to have the same concentration of H plus ions and OH minus ions, then I'm going to have a neutral solution which is going to have a pH of 7. So what we have then is we have our pH scale with 1 being very acidic, 7 being neutral, and 14 being alkaline. So what we're going to do for the time being is we're just going to concentrate on pH of 7 to 1. So if we have a look, the higher the concentration of hydrogen ions, the more acidic and therefore the lower the pH. So let's just have a look in a bit more detail about how this works. Just to note, this is a real oversimplification with inaccurate numbers, but we're just using easy numbers to make sense of this. So let's say, for example, I have a solution here which has a pH of 7 and it has 0 H plus ions. Then it's also got 0 OH minus ions. They're all joined together just to form H2O. Again, it's not quite as simple as that, but we'll go with it for the time being. Then what happens is if I have a solution here with a pH of 6, I end up with 1, 2, 3, 4, 5, 6, 7, 8. I don't want to draw them all out, but I end up with 10 hydrogen ions present. And then if I go to a pH of 5, I then have a solution which has 100 hydrogen ions. Let's imagine that this stays the same volume. Then if I was to go to pH of 4, I'm going to need to have 1000 hydrogen ions. A pH of 3 is going to require 10,000 hydrogen ions. So what's actually happening is we are increasing by times 10, by times 10 again, by times 10 again. And if I just said, oh, I don't know, this just had 1 hydrogen ion, then that's going to make sense. That's times 10. Okay, and then as I carry on going, so a pH of 2 is going to have 100,000 hydrogen ions, and a pH of 1 is going to have 1,000,000 hydrogen ions. So if I want to go down the pH scale by 1 number, I will have to times the amount of hydrogen ions I have by 10. If I was to go in the other direction, let's say, for example, if I was to come up the pH scale, then I would simply just divide the amount of hydrogen ions by 10. And let's have a think about why this is important. Okay, so I've made the point then that to go 1 down on the pH scale, you're timesing by 10, and to go 1 up on the pH scale, you need to divide the concentration of hydrogen ions by 10. So we can get rid of this drawing here, and we can just write that point somewhere at the top, just to make it clear. So I'm going with up 1 is divide by 10. If you went up 2, you'd be dividing by 100, and if you went up 3, you'd be dividing by 1000, as I divide by 10 and divide by 10 again. And then if I was to go up 4, I'd be dividing by 10,000, and then I could count on going so and so and so. And that would be the same with going down the pH scale, but I'm not going to write that because I'm just going to talk about moving up, so making something less acidic. So let's imagine I have a situation where I have an acid. Again, this is a bit unrealistic, but we're going to go with it. If I had an acid that had a concentration of, let's say, 10 grams of this acid put into a 1 decimeter cubed volume. So therefore, the concentration of this would be 10 grams per dm cubed. Then what I'm going to do is I'm going to dilute this acid into a larger container full of water, and then this container is 10 dm cubed, almost like a bit like a trough. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I've got 10 grams per dm cubed, and this is going to be diluted. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, what's my concentration here? Well, if I was to split this into dm cubes, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I just have 1 gram per dm cubed. So my concentration is now going to have changed to 1 gram per dm cubed. So the question is, if I went from 10 grams to dm cubed to 1 gram per dm cubed, what is going to have happened to my pH? So that's really the question. So I can get rid of all of this, and I can say that if I had an acid which had 10 grams of dm cubed as its concentration, let's say, for example, its pH was 2, what is going to be its new pH if it ends up being diluted to 1 gram per dm cubed? Well, let's have a look at what's happened. In order to go from 10 to 1, I have divided by 10. And I can work that out by just going 10 divided by 1 gives me 10, so I've divided by 10. So therefore, I have going to go up 1 on the pH scale to 3. Okay, let's have a look at another one. Let's say, for example, I have a situation where I have an acid which is 0.1 gram per dm cubed. This is the concentration, and my pH is, let's say, 3. And I dilute this acid to 0.001 gram per dm cubed, and I want to know what the new pH is going to be. So if you can pause the video and work out what you think the new pH is going to be. Okay, so hopefully you've done that, and you will be aware that this is being divided by 10, and hang on a second. This is being divided by, if I was to do this, 0.1 divided by 0.001, then that is going to give me an answer of 100. So this is being divided by 100. So therefore, if I'm looking at my scale over here, I'm going to be going up 2, because I've divided by 10 and then divided by 10 again to go from 0.1 to 0.001. So therefore, I'm going to have to go from pH 3 to, this time, pH 5. Okay, so then let's have a look at another one. And let's say, for example, I had a situation where I had an acid that had a concentration of 2 grams per dm cubed and a pH of 1.3. It got diluted to 0.02 grams per dm cubed, and I want to know what is going to be the new pH. So pause the video and have a go at this one. Okay, so if you've done that and you realise that this has been divided by 100 again, and so therefore if it's been divided by 100, it's going to be going up 2 on the pH scale to 2.23.3. So its new pH is going to be 3.3.